Hello students. Students, in our previous lecture we have discussed about Coulomb's law. We have seen that in 1785 French physicist Charles Augustin Coulomb measured the electrostatic force acting between two stationary point charges with the help of torsion valence, and he formulated his observations in the form of a law which is known as Coulomb's law. Now, according to the Coulomb's law, the electrostatic force acting between two stationary point charges is number one, directly proportional to the product of the magnitude of the two charges, and it is inversely proportional to the square of the distance between the 2 point charges, right? Now in this lecture we are going to express this Coulomb's law in vector form, how it looks like in a vector form. Now for this, student, consider the two-dimensional coordinate system. Two-dimensional coordinate system, this is OX and OY, alright, where O is the origin. Now in this two-dimensional coordinate system, let us consider two point charges Q1 and Q2. They are placed at points A and B, whose position vectors with respect to origin O are R1 vector and R2 vector. Now student, let us consider these two charges Q1 and Q2 are of the same type and they are of positive nature. Now in this situation, these two charges Q1 and Q2, they will exert force on each other. Now in this case, the charge Q1 will exert a force represented by F21 vector on charge Q2, and charge Q2 will exert a force F12 vector on charge Q1. So here this F21 vector, this is what? This is the force exerted by charge Q1 on charge Q2, right? And F12 vector, this is what? This is force exerted by charge Q2 on charge Q1, all right? Now we know that the magnitudes of these two forces can be easily given by the relation F21 or F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, where R square is the distance between the 2 point charges Q1 and Q2, right? In this case, if we express these F21 vector and F12 vector in vector form, then their equations will be F12 vector, this will be what? This is equal to 1 upon 4 pi epsilon naught, right, Q1 into Q2 upon आपको क्या करना है, यहाँ से यहाँ तक की डिस्टेंस को जो है वो कंसीडर करना है. तो इट मीन्स इसको मैंने यहाँ पर रिप्रेजेंट किया है R21 वेक्टर से, राइट. सो दिस विल बी इक्वल टू मैग्नीट्यूड ऑफ R21 वेक्टर, its whole square, right? So this is in magnitude form, and here we are interested to represent it in vector form. So this can be written as R21 cap, right, where R21 cap is the unit vector in the direction of R21 vector. 2 से 1 vector की तरफ आपके पास में होगा, right student? Here we know that this R21 vector can be written as, this is R R21 vector, R21 cap can be written as R21 vector upon modulus of R21 vector. Alright, so this force can be written as F12 vector. This can also be written as 1 upon 4 pi epsilon naught Q1 Q2 upon R21 vector its modulus होल स्क्वायर, और इनटू ये जो आपके पास में यूनिट वेक्टर है इसको आप इस तरीके से लिख सकते हैं, दिस इज R21 वेक्टर upon modulus of R21 vector. So finally you can write this equation as F12 vector is equal to 1 upon 4 pi epsilon naught, right, Q1 Q2 upon R21 vector its modulus whole cube into R21 vector. So this is the expression of the Coulomb's law or the Coulomb's force, right, acting between the 2 point charges Q1 and Q2. Now here we can also write down this F21 vector as in the same way 1 upon 4 pi epsilon naught, right, Q1 Q2 upon R12 vector its modulus whole cube into R12 cap, right. तो फोर्स F21 वेक्टर, फोर्स ऑन 2 ड्यू टू 1, तो उसकी डायरेक्शन ये, तो डिस्टेंस आपका ये कंसीडर होगा 1 से 2 की तरफ, तो हम इसको इस तरीके से लिख सकते हैं, राइट. सो दीज आर दी फोर्सेस विच आर रिप्रेजेंटेड इन दी वेक्टर फॉर्म. नाउ दीज फोर्सेस they indicate that they are acting. Here the F12 vector and F21 vector are acting along the line joining the two charges Q1 and Q2, right. So they are the central forces, they are the central forces, right. Here you can conclude that the force F12 vector and F21 vector, they are the central forces. Central forces means they are acting along the line joining the two charges, right. Now in this situation, this R2 or you can say R12 vector, this is equal to minus of R21 vector, right. यानी यहाँ से ये या फिर इस पॉइंट से ये पॉइंट तक का जो डिस्प्लेसमेंट वेक्टर है वो सेम है, उनके मैग्नीट्यूड सेम है, बस डायरेक्शन क्या है, अपोजिट है. सो from this equation we can write this F12 vector, this is equal to minus of F21 vector, right student. तो एक बहुत ही important point है. This indicates that the Coulomb's forces, this indicates that the Coulomb's forces follows the Newton's third law of motion. Means for every action there is always equal and opposite reaction, right. So this is what the Coulomb's law in vector form. So this equation and this equation, they are the vector representation of the Coulomb's force acting between the two stationary point charges Q1 and Q2, right student. तो ये एक बहुत ही important topic है स्टूडेंट, आप इसको ध्यान रखिएगा, राइट. तो मैं इसको यहीं फिनिश करता हूँ. थैंक यू स्टूडेंट, थैंक यू वेरी मच.